Good afternoon, everyone. In this video, I'm going to talk about the quadratic formula again. So if you're watching this, I'm assuming that you've already seen it before and you've already memorized the formula by head, of course. Since I know most of you haven't memorized it by now, I'm just going to write it down, and maybe I'm going to brainwash you so that by the end of this chapter you do actually memorize it. Remember, it basically consists out of two parts. The first part is to calculate a discriminant with the formula d equals b squared minus 4ac, and then can calculate x with minus b plus or minus the square root of d over 2a. And we're going to use this to solve our equation. The thing is, there are actually two ways to solve this one, and I want to show you both methods. During a test, both of these methods would be fine as long as you know the answer is correct. So let's start with method 1, which is known to you as the product sum method. If this is the equation, and you want to use the product sum method, then most of you want to remove that too. And to remove it, you can use eraser, but you're not allowed to do that. You have to divide everything with 2, which is actually allowed. And then you get x squared plus 2.5x minus 6 is 0. And then most of you would say, okay, there's a half over here, so I probably can't use the product sum method. The thing is, you can. There are ways to find 6 when one of your numbers, for example, is a half and the other one isn't. People who are really good at arithmetic are able to use the product sum method over here, and then they would tell me, okay, well, if I use the numbers 4 and minus 1.5, then 4 times minus 1.5 is minus 6, and 4 plus 1.5 is, plus minus 1.5 is 2.5. And then it does make some sense, and then you can fill both of these numbers in. So 4x plus 4 and x minus 1.5 equals 0. Then you could say that x plus 4 is 0, or x minus 1.5 is 0. So x is minus 4, or x is 1.5. Yeah, but the thing is, most of you are probably not able to find these numbers over here. And then this is allowed and possible, but most of you would probably use method 2, which is the product, or not the product sum method, the quadratic formula. And to do so, you basically always calculate the discriminant first, because then, if there are no solutions, you already know that. In this case, we do know that there are 2 solutions, but I want the discriminant for the formula. So in this case, first I'm going to write down A, B, and C. A is 2, B is 5, and C is minus 12. Remember, if there's a minus over here, these numbers are negative as well. So D is B squared, which is 5 squared minus 4 times A, which is 2, times C minus 12. Maybe you can do this by head, maybe you cannot do this by head. This is 121. Since this is positive, it means that there are 2 solutions, and you will actually be able to find them, and we already knew that so far everything is working out as expected. So now we're going to try and calculate our first x, which we'll do by taking minus b minus 5, plus the square root of d, which is the square root of 121 in our case, and then divide this with 2 times a, which is 2 times 2. Minus 5 plus 11 is 6, divided by 4 is 1.5. And our first solution is here again, which is good, because we want to find the same thing, because otherwise one of our methods would probably be incorrect. Then the other one, minus 5 minus the square root of d minus square root of 121 divided by 2 times 2. Keep in mind the only difference between those two expressions is the plus and the minus. In this case, minus 5 minus 11 is minus 16 divided by 4 is minus 4. Hey, our answers are the same. So use whatever method you like as long as it's correct. Could we have also used completing the square over here? Theoretically, I would have to say yes, but yeah, it would be a lot harder than method 1 actually, so I'm not going to show you that. Then example 2, because I wrote down 2 examples. We have a function fx equals a quarter of x squared plus 2x minus 5, and we have to find a and b. Well, they're over there, which means we found a and b. So this is the end of example 2. Hopefully you understood this video, and if you have any questions about the homework, just let me know. Probably Fenna is thinking like, okay, that's not funny, and she's probably correct. Still trying. We actually will have to find the coordinates of these points. I don't know why I did this. Sometimes I hate myself for doing these things. If I want to find these 2 points, the first thing which you should know is those are x-intercepts. So A and B are x-intercepts. And since they are x-intercepts, it means that at those coordinates, dy is equal to 0. So what are we going to do? We're going to take this function, we're going to say that the answer has to be 0. So a quarter of x squared plus 2x minus 5 is equal to 0. Okay. Then there are once again multiple ways of doing this. You can multiply everything with 4, and then you would get x squared plus 8x minus 20 equals 0. Then you can use the product sum method with x plus 10, x minus 2. Then x plus 10 is equal to 0, or x minus 2 is equal to 0. And then x equals minus 10, or x equals 2. But I also wanted to do this with the products, I also want to do this with the quadratic formula, just to show you it over and over. If I'm using the product sum, if I'm using the quadratic formula, I'm starting with d, and in this case, the discriminant would be b squared. So first we need a, b, and c. A is 1 quarter, b is 2, c is minus 5. So the discriminant would be 2 squared minus 4 times a quarter times minus 5, which is 4 minus 1 times minus 5 is 5, so 4 plus 5 is 9. The fact that the discriminant is positive means that there are once again 2 solutions, which makes sense because we want to find the coordinates of both a and b, and if this would have been negative, then we would actually have a problem. But since we don't have a negative number, there will be something for the next video, so maybe this is some sort of a spoiler, but hopefully you will watch it anyway. So now we can use the products, the quadratic formula, x equals minus b, which means minus 2, plus the square root of d, which is the square root of 9, divided by 2 times a quarter. Minus 2 plus 3 is 1. 1 divided by a half is 2. Hey, this should make you happy. Maybe this only makes math teachers happy. And in this case, I'm doing the same thing, but then with minus instead of plus. So minus 2 minus 3 is minus 5, divided by a half is minus 10. And right now, we see that that's good. But we haven't found the coordinates of A and B yet, but we're nearly there. Since we do know that the y coordinates of both these things is 0, we can say that A is the negative x coordinate minus 10, 0, and B is the coordinates 2, 0. Now we are actually finished with example 2, so good luck.